Hi, my name is Lazar, and my major is electrical engineering.
I'm Aaron, and my major is computer science and engineering.
I'm Andrea, and my major is environmental engineering.
I'm Diana, and my major is electrical engineering.
And we are Group B.
Today we'll be presenting to you our advanced energy vehicle.
We will show you a step-by-step process of the construction of our AV, including the initial and final designs.
The Benny railplane was a form of rail transportation invented by George Benny, which moved along an overhead running railway of propellers. Despite superficial appearances, it was not a monorail, as it used both an overhead running rail and a guide rail below. It was intended to run above controversial railways, separating faster passenger traffic from slower freight traffic. Benny was never able to secure funding for further development and went bankrupt in 1937. The line was demolished for scrap in the 1950s. AEVs are small, autonomous, electric motor-powered, propeller-driven vehicles that are suspended from and maneuvered along monorail track systems hung from the laboratory ceiling. The objectives of the AEV project were to create the most energy-efficient AEV design as possible by designing, testing the design, and then redesigning if necessary. The scenario for the AEV project is to transfer consumers' cargo from the warehouse to the distribution center. This project is important because it provides a green, energy-efficient, and cost-effective delivery option. To meet the objectives and requirements, the AEV was given size, dimensions, and layout constraints.
The project started with each team member brainstorming a prospective design. Using the components of the AEV kit, each team member made an orthographic drawing. When compared, the team noticed the strengths and weaknesses of each model. 3 of the drawings utilized an aerodynamic hood, which was later considered in the final design. To compare the designs, a concept screening sheet was made. This sheet ranked the weight, cost, durability, balance, and aerodynamics of each member's designs. In the end, we decided to combine the strengths of each design to create something entirely new. The team discussed the importance of the AEV weight very thoroughly. The less power the AEV needed to move, the more energy efficient it could be. There was talk about new materials that could be used for the AEV construction. Noting the durability, some ideas were thrown out, like using K'NEX. Balsa wood was purchased to create the final design because of its light weight. In the making of the AEV, the balsa wood was layered to make a sturdier vehicle. The motors were also reversed so that the team did not need to use the reverse command at the start of the program, preventing additional energy usage.
The final weight of the AEV totaled 0.227 kilograms. To balance the weight evenly, the Arduino controller was centered on top of the base towards the front and the battery was centered on the bottom towards the back. The final design used the puller configuration for its motors, and the red hood was removed to attach a metal bracket for connecting to the magnet on the caboose. The coding for our final design started the AEV off at a high speed, then decremented the speed as it approached its stopping points, until the AEV was just barely coasting to a stop. We tried to rely on coasting as little as possible to increase the precision of its stopping position, without having to reverse the motors, which wasted a significant amount of energy. We also used only go-to-position commands because it kept track of the cumulative distance the AV has traveled, so that if there was a problem during one part of the run, it would not throw off the remaining portion. Obstacles we faced during programming the AV include inconsistencies in the charge of the batteries and the different layouts of the tracks between the 2 classrooms.
During the final test, AEV had to be manually stopped at the warehouse entrance gate because it continued coasting past the gate sensor. The rest of the run was completed successfully. Energy analysis table displaying the supplied energy for each part of the code was generated from the experimental results using MATLAB Design Analysis tool. This allowed the team to determine that the total amount of energy used by the AEV during the final testing was 194.5 joules. We believe our AEV is one of the best and efficient designs because of its light weight.
We had a great time working together. Teamwork and cooperation was a big part of the lab.
The final design and testing of our AEV was a success.
Our group learned a lot about the AEV and how it worked. We are glad to be representing the class with our AEV in the showcase. Once again, I'm Lazar Volanovic.
I'm Aaron Christie.
I'm Andrea Patterson.
And I'm Diana Manolo.
And we are Group B.